class, we're about to start lesson 1-3, and this lesson has kind of two main concepts, so we're going to break it into two videos. This first one is all about distance, and when we're talking about the distance between 2 points, we're talking about the length between them. And that length can be found on a number line like it is here. So let's say I want to find the distance between, let's say, A and C. Well, the way you're going to see that is you want to find the length of AC. And when you're talking about the length of something, you do not draw the little line segment on top. This is the way, when you see the two letters like that, that's going to mean the length of that segment. It's a little nuance, but that nuance is important that we are able to distinguish that. So from A to C, you could just count it if it's on the number line. If you are counting it, make sure you don't count this as 1. You would count 1, 2, 3 units. Or you could find the length of CF. And again, you're just finding the distance between point C and point F. That would be the same thing as the distance of F to C. You could count it. But another way to do this is you could just subtract those two numbers. The distance or the length is the same as just subtracting the numbers in between those two things. So what I could do is I could take -4 minus 5, and that would actually give me -9, but you're going to have to take the absolute value of that because we're talking about length. And that might be easier than actually counting, but you could count 1, 2, 3, 4, 5, 6, 7, 8, 9 also. So if you would like a formula, you can write this down. The length of any distance between 2 points is going to be the absolute value of the distance between those numbers. So I'm just using X and X here. If you wanted to, draw this out, this is the way it looks in your book. They have a little line segment and they say point P is at, let's say like X2 and point Q is at X1. Well, you just subtract those numbers. Before we get into the distance formula for any 2 points, we do need to do a little review of the Pythagorean theorem. So this will not just be on a singular number line. This would be like any 2 points. And I'm going to draw the X and Y axis for that. Let's say we have point P here, and that is at some XY value, so let's call that one X1 and Y1. And we have point Q here, and that's at some XY value, so let's call that one X2 and Y2. So if I want to find the distance between those points, I can't just do like I did on the number line and count that out. What I'm going to need to do is think about this more in terms of the Pythagorean theorem. So I need to find the distance between these values and the distance between these values. Well, for this one, those are both these X values. Finding the distance between there, I can just subtract them, just like I did here. So I can take X2 minus X1. For these Y values, the distance or how much that's going up, well, I can subtract Y2 and Y1, just like when you guys were in Algebra 1 and you did slope, and you found the distance between those and you put like the rise over the run for slope. It's kind of the same thing here. Well, if you remember, the Pythagorean theorem says we have A squared, so let's say this is A, plus B squared, we'll say this is B, equals this hypotenuse squared. So let's call that C. A squared plus B squared equals C squared. I'm going through all of this just kind of in a long roundabout way of saying the distance formula comes directly from the Pythagorean theorem. So this distance formula will say that this distance here, so A squared, or we're going to write it out as X2 minus X1 squared plus B squared, which instead of writing B, I'm going to write Y2 minus Y1, there's the bell, squared, equals c squared. And in the distance formula, it doesn't say c squared. What it does is it takes the square root of that. So it says that this is going to be the square root of that is going to equal the length of that hypotenuse, or in this case, the length of PQ. So the distance formula and the Pythagorean theorem are kind of one and the same, just different variables that they're using for that. I will show you the next example using the distance formula, and we'll go back and we'll check it with the Pythagorean theorem. So for this example here, it says they want us to find the distance between these points. So I'm going to take a minute to graph these points. -4, -6 would be there, and it's not labeled. Like that last example said PQ. These could be whatever points. And then the next one is at 5, -1. So I'll graph that. And I have a little straight line tool that I'll use. Another bell. The distance between those. So what I'm doing is I want to find the distance between those x values. So those x values are -4 and +5. So you may just be able to tell that that distance between those is 9. Just in case you can't tell, I'm still going to write this out. And it doesn't really matter what order you're subtracting these because we're going to square it and it'll make it positive either way. So the two x values and then the two y values. So -1, -1 minus -6 squared. So we have to remember here that when we subtract negatives, we're adding the opposite. Again, you might be able to just kind of do this in your head, or you could even like count the distance if you want to, if you have it on graph paper. So 9 squared plus 5 squared. 9 squared is 81. 5 squared is 25. So when you add those up, you get the square root of 106. And sometimes it might just want you to leave it as the square root of 106. Other times it might say that they want you to round it off. If you grab a calculator and type in the square root of 106, I need to grab my calculator quick, about 10.3. So when I'm doing problems like this, it's always really helpful if you're checking it on your calculator too, just to make sure you know how to type this in. Okay. If we want a little double check, I could draw a right triangle here just by drawing it straight across and straight up and down and make that right angle. If I count how far this is, that's going to be 9. If I count how far this is, that's going to be 5. And the Pythagorean theorem would say that a squared plus b squared equals the hypotenuse, which would be the distance here, c squared. And you can see that the work is essentially the same. I have 106, and then I'm going to take the square root of each of those sides. So it's the square root of 106 either way. The formula works out pretty well when you don't have graph paper that you're doing it on. If it's on graph paper and you want to think of it more in terms of the Pythagorean theorem, that would be awesome too.